Hello dear students, hope you are doing fine. So in this video we'll start a new chapter, that is alcohol, phenol and ether. First let us try to know what is alcohol and phenol. Now the compounds containing OH functional group are known as alcohol and phenol. Now, if the hydrocarbon is aliphatic in nature, it gives alcohol. Whereas, if the hydrocarbon is aromatic, that is benzene, it gives phenol. OH, the prefix name for OH is hydroxy. That is, when OH gets a secondary preference, we use the prefix name, that is hydroxy. Whereas, when it gets the primary preference, we use the suffix name, that is OL. So, in alkene, E is replaced by OL. Now, the general formula for alcohol is CnH2n plus 1 OH or ROH, where R represents alkyl group. Next, let us see the classification of alcohol. So the first classification is based on number of OH group. So in a compound, in an alcoholic compound, we can have one or more than one OH group. If we have one OH group, say CH3OH, is known as monohydric alcohol, where mono means one. So since you have one OH, is known as monohydric alcohol. If you have two OH in a compound, CH2OH, CH2OH, is known as dihydric alcohol. Similarly, if you have three OH group, is known as trihydric alcohol. And if you have more than three, is known as polyhydric alcohol. One example of polyhydric alcohol is glucose. Next classification is based on carbon using sp3 hybridizing OH bond, that is CsP3 OH bond. First we have primary, secondary and tertiary. So the carbon with OH group. So if this carbon is attached to only one carbon, it gives primary alcohol. If it is attached to two carbons, it gives secondary alcohol. And if it is attached to three carbons, it gives tertiary alcohol. So here in this compound, CH3H8. So this is an example of primary alcohol. If you have COH bond where the carbon is attached to two alkyl group, or say is bonded to two carbon atom, is known as secondary. And if it is attached to three alkyl group that is bonded to three carbon atom, is known as tertiary. Next is allylic alcohol. So in allylic alcohol, the OH group will be attached to sp3 carbon, which will be followed by sp2 carbon. So you can see here, OH is attached to this carbon, which uses sp3 hybridization, followed by a carbon which uses sp2 hybridization. So this is an example of allylic alcohol. Next is benzylic alcohol. So in case of benzylic alcohol, OH group will be attached to sp3 carbon, which is followed by phenyl ring. So this is an example of benzylic alcohol. Next is compound containing carbon with sp2 hybridization bonded to OH group. Is arylic, is known as arylic alcohol. In arylic alcohol, the OH group is directly attached to aromatic hydrocarbon like benzene. So the name of this compound is phenol. Now next, let us see the nomenclature of alcohol phenol. So in nomenclature, we studied two different types of name, that is common name and IUPAC name. So for alcohol, the common name is written as alkyl alcohol, whereas the IUPAC name is written as alkanol. E of the alkane is replaced by OL. Let us take some examples. CH3OH. So in this compound of alcohol, you have only one carbon. So the common name is methyl. Since you have one carbon, the alkyl name is methyl. So it's methyl alcohol. Whereas the IUPAC name, alkene. Since you have one carbon, the alkene name is methane, M-E-T-H-A-N-E. And E is replaced by OL. So the IUPAC name for CH3OH is methanol. Next, C2H5OH. Common name for this compound is ethyl. Since you have two carbon, the alkyl name is ethyl. So it's ethyl alcohol. Whereas the IUPAC name is ethanol. So it's CH3, CH, OH, CH3. Now in this compound, the OH group is not present with the terminal carbon. So for this compound, first you'll find out the longest possible carbon chain. So the longest possible carbon chain for this compound is 1, 2, 3. Chain with 3 carbon atoms. Next, you'll number it in such a way that OH gets the lowest position. So if you go from right to left, 1, 2, OH will get position 2. From left to right, 1, 2. OH will again get the same position, that is position 2. So you can count from either side. So let us take 1, 2, 3. Longest possible chain, 3 carbon atoms. So the alkene name is propane. And OH group is present at carbon 2. So it's important to mention the position of OH group before writing OL. So this will be propane 2O. Next example, CH3, CH, OH, CH2, CH2, OH. Again, find out the longest possible chain. So 1, 2, 3, 4. There are 4 carbon atoms. Now if you go from right to left, 1, 2, 3. So we have 2 OH and the position of the 2 OH group is 1 and 3. If you go from left to right, 1, 2, 3, 4. So it's 2 and 4. So we'll prefer 1 and 3. So we'll start the counting from right hand side. So this is carbon 1, carbon 2, carbon 3, and carbon 4. So the alkene name for the hydrocarbon with 4 carbon atoms is butane. Now E is replaced by OL. But before that, we need to write the position of OH group. So one OH is present at carbon 1 and the second OH is present at carbon 3. So you have to mention both the positions. So butane 1, 3. And since you have 2 OH group, we'll use di. So it's di-O. Di means 2. So the RBC name of this compound is butane 1, 3 di-O. Next example, CH3, CHCl, CH2, CH2, OH. Now here you have Cl as substituent. So the substituent name of Cl is chloro. OH is present at this carbon, so this carbon is carbon 1 because OH will get the primary preference. So carbon 1, carbon 2, 3 and 4. At carbon 3 you have a substituent and name of this substituent is chloro. So whenever we write RPC name, we start with the substituent. So we'll first write the name of the substituent, that is 3-chloro. Now in the chain you have 4 carbon atoms, so it's butane. E is replaced by OL. Since OH is present at the terminal carbon, it's not necessary to mention the position of OH group. Let us take the next example. Now, this is an example of arylic alcohol. The OH group is present at this carbon, so this carbon will be carbon 1. Now, we know in case of arylic hydrocarbon, the counting is done either in clockwise direction or anti-clockwise direction. So if we go in clockwise direction, the position of substituent is carbon 2. But if we go in anti-clockwise direction, the position of chloro will be 1, 2, 3, 4, 5, 6. Position 6. So we'll prefer position 2 over position 6. So the counting will be done in clockwise direction. So the name of this compound is 2-chloro. Now benzene ring with OH is known as phenol. So it's 2-chlorophenol. Next example, OH, NO2, NO2, NO2. NO2, the substituent name is nitro. Now this is carbon 1, carbon 2, 3, 4, 5, 6. So you have free substituent of nitro present at carbon 2, carbon 4 and carbon 6. So the RPC name of this compound is 2, 4, 6. We'll use the prefix tri because you have 3 nitro group. So it's tri, nitro, and benzene ring with OH is known as phenol. So the RPC name of this compound is 2,4,6 trinitrophenol. Take some more examples from the exercise and you practice yourself, the nomenclature part. So next we'll go to the preparation of alcohol. So there are different types of methods which can be used for the preparation of alcohol. Like we can prepare from alkene, we can prepare from carbonyl compound, we can prepare from Grignard reagent. Okay, so we'll study one by one. So we'll first start with alkene. So we'll see how to prepare alcohol from alkene. Now from alkene, there are two different methods. You can prepare it by direct hydration in presence of an acid, or you can follow hydroboration oxidation method. So we'll see these two methods in the next video. Thank you.